This is Greg Troutline with Offshore Engineer TV, and we're very pleased to be joined again by Aneel Gill, Balmoral, to discuss Balmoral's new scour protection system for offshore wind installations, a system called HexDefence. Aneel, it's great to see you once again. I know that innovation basically comes down to solving some sort of a problem. So to start us off, what specific problem did Balmoral see or hear of in the offshore wind sector that led to the development of HexDefence?
Yeah, it's great to see you again, Greg, as well. So we are constantly innovating our products, and one of the main products that we do at Balmoral is actually called a cable protection system, and that's where it's protecting the cable as it's coming out from a monopile or a jacket configuration, taking it past a traditional scour protection, which is rock, typically rock, and then going into a buried scenario. And what we were actually looking at was, how do we diminish accelerated flow, which is a phenomena of water going past a cylindrical object, because that's important to us from a cable protection perspective. It increases loads. We had a product that we knew was very good in terms of its hydrodynamic performance, hydrodynamic shape within the oil and gas sector, and that was our LDV product. Looking at those feasibilities, what we found was a reduction in accelerated flow. Great, okay, stage one, good. But we also noticed a reduction in turbulent kinetic energy. And we used that as a kind of indicator to say, maybe there's something else here. Maybe this can also reduce the shear stress at seabed, which is a key factor of the phenomena of scour. And so we followed up on that, and eventually where we are now, where we've done tank testing, we've done CFD work, and really shown that the product has some really strong performance when it comes to an alternative method to scour protection.
So, can we kind of get just kind of hands-on? I mean, how specifically does HexDefence work?
It's not some sort of magical device, right? All we are really doing here is redistributing flow. And if we redistribute flow, we're redistributing energy, and we're dropping the load cases which are occurring on the seabed. And if you think about it like a particle of sand or a particle of rock, there's a certain amount of energy that it takes to move that particle. So if we're able to drop the energies down at the seabed, we're able to stabilize it, make it less prone to erosion or the forces occurring as the current is passing through or past the object, the structure within the water column. So there's a bit more to it than in a nutshell. That's kind of what we're doing. We're redistributing energy. We're moving current flow away from concentrating it on the seabed.
Obviously, Balmoral's long tenured in the offshore environment, and I'm sure material science is as central to everything that you do. But can you discuss a little bit more about the materials that are used for HexDefence? How long are they designed to last, and what, if any, specific or special maintenance do they require?
Yeah, absolutely. So we can touch on them briefly. Right now, we're looking at a couple of different options. Both have different ways of manufacture, also have different advantages. One, of course, being, you've probably seen it on our website, which is a GRP or an epoxy-based system. Again, these systems are designed to be used in a seawater environment for 30 years plus, including all hydrolysis, aging, all of those testings have to occur to make sure that our materials are good. We're also looking at other materials, things like concrete and items like that, which again have a different cost structure, but also have a different advantages as well. Things like ballast, weight, mass, which also helps with the product and making it more stable when it's around a monopile.
We talk a lot about in our pages about obviously all offshore energy, offshore oil and gas, offshore wind, but increasingly you talk about this technology transfer from traditional oil and gas. So the HexDefence, did that come exclusively then from the oil and gas sector, or I guess can you give me
its inception came from the oil and gas, so it's just that spark, that it develops from there. So Yes, it was a spark from oil and gas, but to be honest, I don't like separating them now. They're all marine engineering, in my opinion. You know, if you have something in the water column used in oil and gas, yes, okay, maybe the risk profiles are slightly different. However, the importance of something being used subsea for 30 years, whether it's oil and gas, whether it's renewables, really the thought process, the technology, all should be very similar. Yeah, so I'm a firm believer in it's all marine engineering now, in my opinion, you know, and not trying to distinguish between oil and gas and renewables.
With the projected pace of offshore wind and installations in the coming decades, you know, as you know better than I, efficient installation of monopiles is paramount, and all subsea structure is paramount to profitability. That said, what is the specific process to install HexDefence, and how does it save time or money in terms of alternative methods that owner operators might consider?
Yeah, so again, a great question, Greg. So when we've looked at it, we have had discussions with developers, we've had discussions with installers, to really, we need that discussion at an early stage to try and hone in on a installation process that works for, you know, remember we're a manufacturer, so it's got to work for maybe the EPCI contractor, or maybe it's the developers taking on the responsibility themselves. And so working with them, we've come up with some basic strategies on how to do these installs. And the idea being it's sleeved over a monopile structure, and that's utilizing the same vessel, the same lift vessels that we would use for, let's say, the transition pieces, which have to also get fitted. That's one scenario. There are obviously different scenarios within the different installation strategies that that happen for different fields. But one scenario would be that. The idea here really is the total cost of ownership. You know, it's not just saying, okay, we're going to put HexDefence on. It's about saying we'll put HexDefence on, and we're able to reduce the level of rock dumping, so that eliminates the need for a number of vessels. It's also saying we're able to bury our cable much closer to the monopile. Therefore, it's to have a reduced dynamic length, making the load cases much more easier to contain on things like cables. Again, we're thinking longevity. We're thinking, what can we do for the total cost of ownership of the field, and not just we want to do one product, we want to do that. That's fine, that's great, but we want to try and have it as part of a system that that helps the industry, not just one aspect of it. And that's where we see a lot of the time saving, a lot of OPEX costs being saved, in really improving the lifespan of cables, improving the lifespan of not having to go and redo a rock dumping operation after the fact. Also improvements in terms of the motion of sequence of events. You may have an opportunity where a rock dumping vessel isn't available. It's just we know the numbers are going up, and we also know that the vessels are they're very tightly scheduled, and so it opens up an operational window to perhaps do something in 5 years' time, whilst having HexDefence in there at the time of install. So it gives a lot of flexibility to operators as well, which again is one of the key things we want to try and offer our customers.